Namaste, this is Niraimati, Faculty in Electronics from Bhavan Vivekananda College of Science, Humanities and Commerce, Sainikpuri, Secunderabad. In today's class, we are going to discuss about understanding Kirchhoff's laws and applications. The topics for discussion includes Introduction to Kirchhoff's laws, Kirchhoff's current law, Kirchhoff's voltage law and their applications to simple circuits, circuit analysis techniques that use Kirchhoff's laws, and finally advantages and limitations of Kirchhoff's laws. Kirchhoff's laws were first formulated by Gustav Robert Kirchhoff. He is a German physicist who has given one of the greatest contributions to circuit analysis. The Kirchhoff's laws are Kirchhoff's voltage law and Kirchhoff's current law, and they were called after this physicist as Kirchhoff's laws. Let's move on to the individual laws of Kirchhoff. Kirchhoff's current law. So Kirchhoff's current law states that in any electric circuit, the sum of currents entering a particular node or a junction is equal to the sum of currents leaving the node. So here we have taken an example of a portion of a network where there is a node A and at which we have certain resistors connected, and there are certain currents flowing through these resistors. Some of the currents are entering and some of the currents are leaving. So we can see that current IA is flowing towards A, whereas IB, IC and ID are flowing away from the node. So current entering the node is IA, currents leaving the node A are IB, IC and ID. So as per Kirchhoff's current law, IA is given as IB plus IC plus ID. So here we have a simple electric circuit that has got a single node X. So at this node we have certain resistors connected R1, R2 and R3, and there are certain currents flowing through these resistors. I1 is the current flowing through R1 towards X. I2 and I3 are the currents which are flowing away from X through R2 and R3. Therefore, as per Kirchhoff's current law, I1 is equal to I2 plus I3. Here we have a slightly larger problem where we have a network that has got two junctions. The junctions or nodes are labeled as X and Y. At X we have three circuit elements meeting. So current I1 is entering X, I2 and I3 are leaving the node, and therefore by Kirchhoff's current law, I1 is equal to I2 plus I3. Such equations are called as node equations. So this is the node equation at node X. Let's move on to applying Kirchhoff's current law to node Y. So at node Y again we have three circuit elements connected, which are R4, R3 and R5, and the currents associated with these three circuit elements are I3, I4 and I5 respectively, and I3 is entering the node, I3 and I4 and I5 are leaving the node, and therefore by Kirchhoff's current law, I3 is equal to I4 plus I5, and this is the node equation at node Y. So we can observe in these two examples that there are as many number of equations as the number of nodes. So when we have a circuit with a number of nodes, we will be able to apply Kirchhoff's current law, write node equations. Upon solving the node equations, any network problem can be solved. Moving on to Kirchhoff's voltage law. Kirchhoff's voltage law states that sum of voltages around any closed loop is equal to 0. In other words, the law also can be stated that the total sum of potential rise in a closed loop is equal to the total sum of voltage drop in a closed loop. closed loop. Closed loop refers to any closed path in a circuit. And Kirchhoff's voltage law will be following the principle of Ohm's law. So since it is following the principle of Ohm's law, let's try and understand what is Ohm's law and the sign convention used by current and voltage. So here we have a resistor R, and there is a current I that is passed through the resistor R with a specific direction, and this current will be setting up a voltage across the resistor, and the voltage setup across the resistor will have this polarity as per, that is a sign convention normally used. So by Ohm's law, V is given as I into R. So if a certain amount of current is passed through a resistor, say let us suppose that a current of 1 ampere is passed through a resistance of 5 ohm, then the voltage set up across the resistor will be 5 volts. Just in case we pass a current of minus 1 ampere through the same resistor, then the voltage set up across the resistor will be minus 5 volts. Mathematically this is correct. But technically speaking, when we say we are passing a current of minus 1 ampere through this resistor, it means that we reverse the direction of the current I and pass a current of plus 5 ampere like this. We simply reverse the direction of the current. So when we reverse the direction of the current, the polarity of the voltage also will be changing, as you can compare and check it. So whenever the direction of the current is reversing, the polarity of the voltage will be changing. Let us try and understand what is potential rise and what is potential drop across a resistor or even in a source of EMF. We say that there is a potential rise when we traverse through any circuit element from negative marked terminal towards positive marked terminal. So here we have a resistor, and due to some current that is passing through resistor, a voltage can be set up, and that voltage could have polarity as labeled like this. So in this case, the direction of traverse through the resistor is from negative marked terminal towards positive marked terminal. So in such a case, we say that there is a potential rise. So in that case, this V is a potential rise. On the other hand, if the direction of traverse is from positive marked terminal towards negative marked terminal, then there will be a potential drop. So in that case, V is a potential drop. In the third example, the direction of traverse is from negative marked terminal towards positive marked terminal, and hence this V is also a potential rise. And similar analogy is also applicable to sources of EMF. So here we have a source of EMF. So this source could be a battery which has an EMF of V volts. So DC power supply will have polarity. So this arrowhead indicates the direction of traverse. So when the direction of traverse is from negative marked terminal towards positive marked terminal through a battery or through a source of EMF, then the EMF will be treated as potential rise. On the other hand, if the direction of traverse is from positive marked terminal towards negative marked terminal, then the potential is considered to be potential drop. So here the traverse is from positive marked terminal towards negative marked terminal, and hence this EMF will be a potential drop. So having known these basics, let us go and apply Kirchhoff's voltage law to this simple circuit. So this simple circuit has got a source of EMF V and certain resistors R1, R2, R3 and R4. And this circuit, as you can see, has got two closed paths. And in order to define the closed paths, I am going to label the nodes. I am going to label the vertices or nodes. So the nodes are A, B, C, D, E, F. So loop refers to a closed circuit, as we all know. So a path starting from point A to B, E, F and A is a closed path. So, this is loop, and the second one can be starting from B to C, D, E and B. So, this can be a second loop. So, this circuit has got two basic loops. So, in these loops Kirchhoff's voltage law can be applied. So, loop 1, that is the loop AB, EF, A contains circuit elements V, resistances R1 and R2. And similarly, loop 2 contains resistors R2, R3 and R4. Let us assume that there are certain currents flowing through these resistors, I1 through R1, I2 through R2 and I3 through both R3 and R4. R3 and R4 being series to each other, same current will flow. So, these currents will be setting up voltages across R1, R2, R3 and R4, and the voltages are V1 across R1 with the designated polarity, V2 across R2, V3 across R3 and V4 across R4. So, now when we apply Kirchhoff's voltage law, we can see that if we traverse in the clockwise direction, let us suppose we traverse from point A. So, from point A to point B there is a potential drop because we traverse from negative mark terminal to positive mark terminal to negative mark terminal, and therefore, this is a potential drop. So, V1 is a potential drop. Then from B to E there is a potential drop. So, V2 is a potential drop. From E to F, no drop, no rise. From F to A there is a potential rise because the direction of traverse is from negative mark terminal to positive mark terminal, and therefore, V is a potential rise. So, as per Kirchhoff's voltage law, sum of potential rise should be equal to sum of potential drop, and therefore, V is equal to V1 plus V2, whereas V1 and V2 are given by Ohm's law as I1 R1 and I2 R2 respectively. So, this is the first loop equation. Moving on to loop 2, we have the path, closed path BC, DE, B. So, when we traverse from B to C, you have a potential drop. So, V3 is a potential drop. C to D there is a potential drop. So, VB is a potential drop. From D to E there is no circuit element. From E to B again there is a potential rise. Okay, and hence we have the equation . And hence we have the equation I2 R2 equal to I3 R3 plus I4 R4. Okay, so this is the second loop equation. So, when we have a circuit having a number of loops, so those many number of loop equations can be written. By simultaneously solving those loop equations, we will be able to solve any circuit problem. When it comes to practical application of Kirchhoff's laws can be used in circuit design. They can be used for troubleshooting electrical problems, and also they are used for analyzing any complex circuit. There are two very important techniques that are used for circuit analysis. They are node voltage analysis. The law that is used for node voltage analysis is Kirchhoff's current law, and the second technique is mesh current analysis. It uses Kirchhoff's voltage law. The advantages are they are simple, universally used and applicable to any type of network. They produce precise results, and limitations are the complexity will increase as we move to larger circuit, and therefore the manual calculation requires a lot of time. Thank you.